Sun, our solar system's single star. But did it once orbit another star? We have just two answers for that question. While both of them end in solitude of Sun, it might be safe to say it wasn't always alone. Astronomers researched that stars like the Sun typically form in clusters with other stars within solar nebulas. Many clusters are spread out so that the stars drift apart, but others are denser, and gravity keeps their stars close together. Meaning, even our Sun was probably born in a group of stars, but later escaped from or simply fell out of this group. It may have been pushed away due to an encounter with another star or a much larger object, such as a molecular cloud. Or, and this scenario is a bit more likely, Sun simply didn't keep pace with its birthmates. As the Sun takes approximately 135 million years to complete an orbit around our galaxy, little variations in the rates of the Sun and the stars born alongside it will gradually disperse over the 5 billion year age of the Sun. Stars traveling slightly slower than Sun got left behind, and on the contrary, those stars that are traveling slightly faster left Sun behind. In the end, the result is a dispersed group of stars who once shared a common beginning. To look for these dispersed solar siblings, astronomers can use the spectrum of light shining from a star of a similar age and tag its chemical makeup, which can then be compared to the Sun's, as multiple stars forming in one cluster tend to have similar chemistry. Origin of Sun is still being researched, although some hinted that the Messier 67, a giant cluster of stars, could well just be it. Before we move to the other theory, leave a comment with your opinion and subscribe. While being part of a cluster family and getting left behind is heartbreaking, some point out that this was not the case and Sun was really part of binary system once. How is that possible? Well, by looking at the icy bodies orbiting past Neptune, which are called the scattered disk, and the Oort cloud, a huge cluster of icy objects, things get interesting. If Sun did form alone, it is hard to imagine it could pull that much of objects together by itself. If instead it were part of a binary system when it was young, the capture physics actually gets easier. As in many cases, the two stars work together to minimize the added energy, allowing objects to be captured by one of the stars. That means the Sun's buddy would had to have been at least 140 billion miles out, assuming it had the same mass as the Sun, as most binary star components have roughly equal mass. Now, I said before that binary systems are far more efficient at capturing objects than single stars. So, if the Oort cloud formed as observed, it would imply that the Sun did in fact have a companion of similar mass that was lost before the Sun left its birth cluster. Essentially, before the loss of the binary, the solar system already would have captured its outer envelope of objects. This being the case, where is the Sun's companion, and how did it get lost? If it ever existed, it's long gone. Sun was born 4.6 billion years ago, and throughout its journey it encountered a lot of stars. Those stars could have passed near Sun's binary system and disrupted it, resulting in loss of companion. It's probable the Sun would have only kept the companion for about 100 million years before losing it. If you want to know more about how stars are formed and what is between star and planet, check this video.